Welcome back, everyone. Thank you for, hopefully you've got some coffee, and it seemed like that session got us all thinking, well, particularly the engineers like me, got us thinking about other issues, which is fantastic. Our final session today is on risk assessment and mitigation strategies. So this is all about supply chains, disruption to supply chains, how we think about risk in these. And our first speaker we've got is Dr. Manoj Hidari, who is a research associate in the HAL group, doing some work on building resilience in critical minerals.
Good afternoon, everyone. I will be showing the first multidimensional map of resilience for the critical minerals supply chain, and where research should pivot based on 327 papers that we reviewed for this research article. Okay, let me start with why this matters now. As we accelerate transition to clean energy technologies, we are building more and more demand for these critical minerals. And this demand is at a scale and pace that global supply chain has never faced before. And that's not just because just about how much material we need, but about what we need. And the minerals that we need now for clean energy technologies are far more complex than it used to be. As you can see in this graph, in 1700, only a handful of minerals were required for energy production, while in today's world, we need a handful of different critical minerals for our energy, EVs, and solar panels. And this is what makes the system very much fragile. And it's not just about what kind of minerals we need, but also where do we find these minerals. And that's the challenge that these critical mineral supply chains are facing now, because these minerals are mainly concentrated in specific regions and countries. For example, cobalt is mainly produced in Congo. We have lithium from Chile and Oceania, Australia. We have rare earth elements, which is mainly dominated by China, and nickel from Indonesia. And this geographic concentration is the reason that the system and the supply chain is facing a lot of disruptions. But to move from headlines to evidence, we needed a structured review of what has been studied so far, what hasn't, and what actually works, which I'm going to present the results of this research article that is under review currently. And in this research, we did a very systematic review, not only keyword search, but a very rigorous and replicable method using a combination of LLMs with Prisma method in order to review the research articles in terms of the mineral type, the region, supply chain stage, disruption factors, and mitigation measures that have been studied by different scholars across the world. And our time frame was 2015 to 2025. And the results of this study gave us the idea of where and for which minerals the risks concentrate. As you can see in this heat map, the frequency of critical minerals is mainly biased towards battery technology minerals. As you can see, is this working? Yeah. Cobalt, lithium, nickel, and rare earth elements were the minerals that were highly investigated by different scholars, while other critical minerals are highly neglected in the research articles. Also, regional exposure is uneven in these researches. As you can see, Africa and Oceania, which are specifically research-rich regions in the world, are highly neglected by the scholars. Also, you can see that in terms of the supply chain stage, demand side of the supply chain is highly neglected by the scholars, and the research is mainly focused on the supply chain in the global scale. Now that we know where the research gap is, let's zoom into the disruptions that we found across all these 327 papers that we analyzed. We found 39 different disruptions in the critical mineral supply chain, and we categorized these disruptions into 7 main categories, as you can see in this graph, which production constraints, the geopolitical and policy disruptions, and market and economic disruptions are the first 3, the kind of disruptions that were repeated very often by the scholars. In the production constraints, it is, I should use this one, I guess. It's the resource scarcity, which was mentioned by most of the scholars as the disruptions happening in the supply chain. For the geopolitical and policy disruptions, it was the export and import bans by different governments and countries. And for the market and economic disruptions, it was the boom-bust cycles in the critical mineral supply chain, which mainly caused different disruptions. Moving to the mitigation measures, let's see what solutions are most discussed by different scholars. We identified 48 mitigation measures across these 327 papers that we analyzed and categorized them into 7 main categories as supply diversification, technological innovation, and market mechanisms were the 3 main mitigation measures that we identified. The first and mostly mentioned supply diversification mitigation measure was the multiple countries and regions as a supplier. For the technological innovation, obviously recycling was the first one that was very much mentioned by different scholars. And for the policy and market mechanisms, it was bilateral or multilateral free trade agreements, which were proposed by scholars as mitigation measures. And to highlight the key takeaways from this research article, we understood that these mitigation actions are widely recommended, but here's why many of them don't translate into actual resilience. First of all, there is an imbalance in the literature coverage as resilience strategies mainly focus on upstream disruptions, and disruptions from midstream and downstream are highly neglected. Second, the mitigation measures are also focused on the supply side of the supply chain and mainly caused by geopolitical tensions, and other kind of mitigation measures are also underexplored in these research articles. And this shows a very huge research map in midstream and downstream of the supply chain. Another blind spot is the technological innovation, which is really crucial, but it is rarely framed as resilience. As demand for critical minerals grows, traditional mining and refining technologies are becoming more and more inadequate. And using innovation in mining and processing significantly can enhance this efficiency, address declining ore grades, minimize environmental impacts, and ensure economic viability in minerals production. Also, integrating a specific ESG criteria operationally within critical mineral supply chains significantly enhances resilience beyond traditional approaches. So let's see what that looks like. Environmental aspect of mining activities is one of the pillars of ESG frameworks, which can increase resource efficiency. It can help with waste minimization and climate risk management. Social aspect is the stabilizer, which helps with capacity building, inclusive community participation, and fair labor practices. And governance is the glue that makes responses fast and coordinated by adaptive risk management, strategic collaboration, and transparent accountability processes. Together, these ESG-driven operational practices can create a resilient, responsive, and sustainable supply chain capable of navigating and adaptive to multifaceted environmental, social, and governance disruptions. We did do one research article on this in this regard, focused on Zambia copper mines, and which is currently under review, and hopefully it will be online very soon for all of you to check. And we did create another research question based on this outcome of this research, that we want to understand, do current ESG frameworks actually capture disruptions and mitigation measures effectively, and can make these practical in the industry. The third outcome of the research was that circularity is actually failing in practice. Although there are a lot of studies in terms of recycling of these lithium-ion batteries or critical minerals, these systems are capital intensive. They require advanced technologies which are still under development, and also there are substantial investments required for scaling and deployment of these technologies. Lack of decentralized and modular recycling system also limits the collection and efficient processing of critical minerals end-of-life scrap, which brings us to our second research question. Can lithium-ion battery recycling practically boost resilience, which we are focusing on this right now to see if this is actually happening in the future. And the fourth outcome is that risk concept is not clear. We identified that there is a need for a stronger theoretical alignment between critical minerals, criticality studies, and classical risk theory, which Baptiste is going to present later on this session. So building on these gaps, I will be following the two research questions that I mentioned already. Thanks for listening, and I'm always open to exchange ideas.
So final talk for today is Baptiste Andreu, who's coming. He's one of the researchers here in our group. Is quite involved in the mapping work that Benjamin presented earlier. But I asked Baptiste to present on this idea of risk theory and whether we're getting criticality and risk right. So
thank you, John. Didn't manage to get Ben to present for me this time. So I did it myself. A shortage of raw materials will have a huge economic impact. And in this context, there is a demand from policymakers to have analysis that would help them know what materials to prioritize when trying to secure supply. And historically, this has been done by critical minerals assessment. So these assessments usually have two dimensions. One of which is called supply risk, but that's not really a supply risk. It's more the probability of a supply disruption. And the other axis, who is sometimes called economic importance, is the vulnerability to such a supply disruption. And this criticality is an abstraction of classical risk. So in risk theory, the equation you see above, you calculate the expected loss associated with a given scenario. So that's the probability of occurrence of something multiplied by the consequence of such a thing happening. And thinking of it in terms of risks will help us to analyze the field of criticality and whether or not the indicators chosen make sense. In particular, some researchers presented this equation, which is just a bit more developed than the above one. So here we have the probability of disruption again, and the vulnerability of disruption. And what this says is that if you want to calculate a risk or criticality, you should integrate over all of the time steps between today and say 2050. So that's the probability of disruption today, in 1 year, in 2 years, etc., times the vulnerability every time. And you also need to study different types of events and different sizes of events. That's the DX here. So the type of event could be a strike, it could be an earthquake, it could be any disruption. And its size means you have to calculate the probability of an earthquake of magnitude 1 and of magnitude 2 and of magnitude 3, and to sum up over all of these probabilities. And of course, you need empirical validation, because in this criticality analysis, they use a bunch of indicators, and you need to show that the indicator you are using for probability actually has a causal relationship between the indicator and what it's supposed to represent, so the probability of disruption, and the same is true for the vulnerability. You need to have the correct mathematical formulations. That's a multiplication of both axes, and we'll come back to this. And finally, you need units. Because when you calculate risk, for example, the risks associated with an earthquake, you're going to calculate the number of buildings that are destroyed or the numbers of people dying from an earthquake. And in the field of criticality, it could be the economic impacts associated with the disruption. It could also be, again, the human impacts in terms of what happens in the mines. Right. So with this in mind, almost 10 years ago, 2 papers were published which analyzed the whole field of criticality through the lens of risk theory, one in 2015 and one in 2017. And the papers were really, really harsh over the field. And especially this one said that the criticality field was flawed in several fundamental ways, including these critiques, but not limited to these. So all of the studies, not a single one at this time, acknowledge the fact that they should take into account different sizes of events. Many studies did not comply with the formal requirements of risk theory, so that is the multiplication of both axes, which we just discussed. And the implications of this can be to have worse than useless outcomes, quoting them. What this means is that sometimes if you take a random ordering of your sample, you will have better results than taking the results from their analysis. And finally, the choices of the indicators in both dimensions were almost never justified empirically and just justified on the intuitions of the authors. This was almost 10 years ago, and so we published, a follow-up, which is under review right now, of this paper, so 10 years on, our raw material criticality assessments, making more sense, and we reviewed every single one of the criticality assessments published since 2017 to see if things had changed. And unfortunately, things have not changed. I'll give a few examples and then see the implications. Okay, so first example, I said we needed a multiplication of both axes. And this means that your contour lines should be convex. And I'll come back to it in the next slide. But some of the analysis still had concave contour lines. This means that the further away a raw material is, the more critical it is. So this means that along this axis, raw materials get more and more critical. But if we replot this exact same thing with the correct point of view, which is the convex lines, it looks like this, and all of these raw materials actually have the same criticality level. So that's one example, but the other one is the example from the European Commission, which published this analysis. They do it every few years, but this is the 2023 one, so it's 8 years after the critique. Here, they have these 2 dimensions, so economic importance and supply risk, which is again probability of supply disruption. And they say that everything above these 2 thresholds is deemed critical and everything under is deemed not critical. And then they say, well, we also know that there's a bunch of raw materials that are important for the energy transition, which we're going to call strategic raw materials. And that's just a political thing. And they say, well, the strategic raw materials are also deemed to be critical. So that's, for example, copper and nickel, which are here in red. And they say these ones are critical. So here again, you don't have the convex lines. And what does this imply? Here I replotted it. So that's the same as what you saw before, but with a few more examples. Natural rubber here is supposed to be not critical because it's in blue. And we plotted the line of constant criticality level when multiplying both axes. And this means that natural rubber has a higher criticality score or all of these than all of these, which are supposed to be not critical. And you can do the other thing. But then what's interesting as well is when you look at copper here and you plot the isocriticality line, it looks like this. So every single one of the, so 89 out of the 90 raw materials are more critical than copper, and the only one which is not is round wood. To me, that's a huge issue because either this dimension is correct, so the probability of supply disruption is indeed 0 for copper, then it's not critical, or it's not, and then you should change the method, but you cannot just change the results when the results don't suit your priorities. Yeah. Anyways, a few more conclusions from that review. Only 17% of the articles had any sort of empirical validation of the vulnerability dimension. Only 7% had validation of the probability dimension. Only 5% did the risk have an actual unit, so that was economic unit. None of them used integrals over effect size, and none of them used integrals over time. And we also checked in all of these papers whether or not they cited the two initial papers that criticized them to see if there was any refutal of their arguments. And we did not find any refutal of the arguments. And a lot of the papers actually miscited these papers and misinterpreted them. Right, so what can we do from this? I see two big work streams which we can tackle. The first one would be to have to actually carry out real risk assessments. But the issue is, if you think of the equation we showed beforehand, the integral over time, over all sorts of size effects, is just incredibly complicated. So we cannot expect to do it with the same scope as the criticality studies which are done today. So we need to reduce the scope. And that's what we are trying to do for lithium, and that's what Ben presented this morning. The first step being to understand the supply chain, not just in terms of supply and demand, but also with everything in between. So we try to map at the company level all of these flows. And then we'll try to see, well, once we have this map, is it possible to have some sort of estimation of the risk associated to the supply chain? And we don't yet know exactly how we'll do it. If you look just at earthquakes, it's easy, for example. I mean, easy, it's doable, because you can have maps of earthquake hazards. You then have historical disruptions due to hazards, and you can calculate a risk. But for other things, other disruptions, it's going to be much, much more complicated. We'll have to answer to questions such as risk for whom, in what unit, for what types of disruptions, over what time frame, etc. The second work stream we are thinking of is to have criticality assessments. So we cannot expect to have real risk assessments, but that would be a bit more empirically grounded. So to do this, we started doing a review of every single one of the indicators ever used in the criticality field. So that's 829 indicators. We're trying to map them to different types of disruptions and whether they could be matched to hazards, vulnerability, or exposure in classical risk theory. Once we'll have this, we'll try to build databases of actual historical disruptions and see if there's any correlation between the intuitions we have about these indicators and the fact that they are indeed correlated with what they're supposed to represent. Because, for example, two big metrics that are used is the concentration of supply and the World Governance Index, or any types of indexes. And preliminary research has shown that there is absolutely no correlation between these indicators and the probability of a supply disruption. And then we'll also try to have ideas about how can criticality assessments be improved, with a special focus on the EU, the US, and Great Britain strategies and like methods to build this, to see, again, yes, what can be improved. All right, I'll stop here. Thank you. And you can have a look at the preprint here.
Okay. Let's get the three speakers back up again. I'll start with a question. You mentioned, I think two of you mentioned risk to whom. And obviously, Malaka, yours was focused on risk in Zambia. But we've got these risks to people buying products, risks in minings, risks in supply chains. Do you want to comment on this risk to whom kind of concept and where you think the main risks are?
I think for me, I think the risk is to everyone, because basically, I think like from an energy point of view, I mean, if the mines continue getting the energy from the power plants within a country, then you are not going to give the local people the chance to have energy, right? But But again, if a government says, "Oh no, you guys, you have to put up your own power plants, for example, and then you have to fund them," again, that's a global risk. I mean, that's a big risk where I think no government can actually do it, because if they do it, then the global trade like will just go haywire, right? So I think it's basically everyone in short. Like I think we are all affected indirectly or indirectly.
Yeah, in this review that we did on these 327 papers, we identified that most of the academic people are focused on risk to buyers and risk to suppliers, mining companies, or indigenous people in the mining communities is underexplored. So I think in the future risk analysis, I would add another indicator as the stakeholders' point of view to have some kind of, I don't know, scenario-based technique to incorporate the kind of ideas of different stakeholders in their kind of risks they are going to be faced, and have that also in the risk assessment. So I think it's going to be important.
Yeah, I'm not sure I have a reply to this, because the risks can be for anyone. But I think what's interesting is also to think of it in terms of units, and because sometimes for example, these criticality indicators are aggregated, but in there you have economic risks for the company and real local risks for the people, and then risks for the environment, and all of these have different metrics. And so how do you choose between them? And it's really about values in the end and ethical things. But then we cannot just stop mining altogether either, because then you have the risk of not doing the energy transition and having climate change, which would be much worse. So yeah, it's unclear to me.
Yeah, and I was going to say it's more complicated with the supply chains, because the risks propagate along the supply chain. So even though we focus on the risk of the buyers, or maybe a wealthy nation getting these materials, if we don't understand the risks at the mine end, then we might not be able to get the materials, or they might become, so the propagation of risks or costs down the supply chains. Question from the audience.
Thank you. Yeah, question for Baptiste, that's okay. You talked about the complexity with doing the kind of classic risk theory approach and needing to do it across time and in all the different magnitudes of the effects. If you then start to think about all of the additional kind of complexities and uncertainties that we've thought about today in terms of material intensities or changes in technology makeup and that sort of thing, do you think it gets so complex that it gets to the point that actually we do just need experts to say, this one is important, this wasn't important, and this one is important, because it's not possible to actually model the true complexity in the kind of classical sense you've laid out?
Yeah, so I think indeed it is way too complicated to say this one is critical and this one is not. But I think a way out of this is to have clear research questions. So are we interested in natural hazards? And then, for example, mines in Australia might be more critical than mines elsewhere. So that's one option. And then the other option is just to have a bunch of indicators, such as those used in criticality, and what each of these implies, and what the policymakers can do to reduce them, but not aggregating them together. Because, for example, this morning, some of you on the panel were asked which one scares you the most, and I'm not sure the ones that were chosen were actually in the criticality list, because it's just everyone has a different view of it. And the risk of having this is that this is then used to allocate resources, and that's public funding from governments all over the world. And so I think it's risky to frame it as if we had the answer. Was I'm not sure we have a good answer.
So I used to be the global risk manager for Syngenta, which is an agrochemical company, and it's, of course, many big companies have exactly this issue, not for critical minerals, but all of the risks. So just, I loved your properly laid out diagrams, well done. But what you would typically have would be at different levels, quantitative where you have quantitative up to qualitative, just like your group does at different levels. But you would also have different scales. So you would have a scale for economics and risk economics. You would have a scale for risk for people or ESG, but you would have therefore a values-driven statement about how you compare them. So, for example, for speaking of a company that I was in, one fatality was equal to £100,000. Right? That sounds very uncomfortable, but when you're going to compare these different things, you need to have a numerical way of doing it. If you have multiple fatalities, what's that the equivalent of? 2 or 2 to 5. Or if you have an environmental impact that would cost this much to retrofit to what would be UK or standards, whatever standards you're going to equate worldwide to. So it's all about your ethics and your values of a company or a country and how you enact them, how you compare these different units, as you put it. And so, and you can't evaluate every single option. If you're the government's National Risk Register, one of the things they do is the most probable option. And myself and others wrote a report as well, that's actually very risky, like you said. But what are the likely worst case scenarios, and then rate 2 or 3 of them rather than all of them? Because the idea is which one, like you rightly said, which ones actually should we go after? But the only way you can do that systematically is if you have some sort of statement that compares economics or biodiversity with environmental risk, people risk. And the reality is today, if you're in the UK, there are a certain set of regulations. If you're in Zambia or where I was born, Tanzania, there's a different set of regulations. And just like you were talking with Gambia, what suddenly changes when there's a problem? Do the people not get electricity? I managed a site in Houston when we had the big hurricanes. Which supply chain took priority? What do you think? Bringing electricity supplies, things to repair electricity lines, medicines? No, the Port of Houston, the priority was given to bananas. Really sensible, right? And that was because there was contracts, just like you said, in Gambia, because bananas perish really quickly. So Del Monte had a contract that said if there was ever a disruption, they got priority because they'd lose all their stock. So you need to check your mitigations, not just for the normal, but when the scenario actually happened. But I've just made it even more complicated.
No, but thank you, because that's central to it. Yeah.
And I'm leading some work with the Royal Academy looking at just that. So I really hope you can come and join us. I mean, he's already been told he needs to be part, but I think
sure.
It's
exciting.
It's a really important thing we need to do a lot more work on. But we also need to look at the political dynamics of the different countries who are operating in this and what their values will be. And we may want to be ethical and biodiverse and all that, but in reality, will we be able to have parity?
I was just wondering if you wanted to talk about what you noticed in the climate change risk and financial risk spaces, how they were more advanced than critical minerals.
Oh yeah, I mean there are lots of fields where they do proper risk analysis over like all steps of supply chains. And this is the example you gave in companies. I mean, it's interesting to see that in big. I mean, and of course they do, because that's And yeah, you have to, and it's about values in the end as well, and economic consequences. So yeah, there are lots of fields that do it properly, and it's, for some reason, it hasn't gone through to the criticality thing. But it's also because the supply chains are way too complicated. So it's like it's undoable to do it properly, and I guess that's why it's not done.
You need a methodology that's acceptable enough to give you the answer you need.
Yes. Yeah.
Yeah, hi, thanks. Yeah, I wanted to kind of from the comment you just gave. I mean, I was interested both from Manush and Baptiste because, I mean, there are specific definitions of, first of all, resilience and criticality, which doesn't exactly mean risk in the fields that I work, which is generally climate risk and resilience, and in infrastructure, especially there's the thing that you're saying, some fields are advanced, and we have a lot of kind of done these kind of methods. And there's also this multi-criteria decision making where you have multiple metrics, not just economic, but social and everything, and you make decisions based on it. I was kind of interested in both of your framings in terms of like essentially the definition of resilience that you've encountered in this field, which I find based on the way you describe it, is a bit different than how resilience is really framed also in the IPCC kind of nomenclature. And also Baptiste from yours in terms of the risk and criticality, the way you were interchangeably using those words, because they are kind of generally used very separately. Criticality is a means towards understanding risk, and it's not exactly risk. So I don't know whether in this you think there's a need for kind of proper definitions as well that doesn't exist in this field.
Yeah, we did analyze about how these different papers actually define resilience, how they define risk or disruption, and there was no correlation between these different researchers. So exactly in critical mineral supply chain, there is a research gap about what everyone means when they say critical to who. What do they mean when they say risk to who? So this is exactly one of the research gaps that we found in this research.
Yeah, there's a paper who just got published on who analyzes, compares resilience and criticality, and gives how each of the sub definitions of resilience could be transposed into criticality and into the vulnerability dimension, basically, of criticality. But to come back on the parallel between risk and criticality, so we just got the reviews from that paper, and one of the reviewers said, yes, but actually basically they were not convinced that risk and criticality should be compared. But what's interesting is when you read all of the foundational papers from criticality, they always come back to probability of disruption and consequence of disruption. And sometimes they use different words and like kind of weird vocabulary, but it always means this. And so if you have these two dimensions, perhaps you're not calling it a risk, but it's like it has to be a risk. And what I mean is that, or at least like even if you don't want to frame it and you don't want to actually do the multiplication and leave them in the matrix without putting contour lines, your indicators should still be empirically based on something. And I think we can have inspiration from the people in risk theory that are much more advanced, as you said, to know how to improve this qualitative analysis.
Yeah, just add something to that. I think your definition of what should be critical depends on what you're using that classification for. So if you're going to call something critical and then allocate resources to minimizing the risk, well, then it makes sense that you're calling the most risky materials critical. So I think the definitions can kind of be informed by what you want to use the output for. And to my mind, it does make sense that the highest risk materials are the ones that we want to dedicate our resources
to. So one of the things between risk and resilience is adaptation after disruption. So there's immediate handling, then the absorption of the risk, how much can you absorb, then the immediate handling, and then your ability to get back up to whatever rate. And I think when you were talking, who was it that had the maps of, it was your work, where you had the proxy for risk with people having moved because of some crisis of refugee camps, etc. And one of the questions I asked there was, how long for? Because if the disruption is only for 3 months, then maybe in a global supply chain that doesn't matter. Whereas if you look at what happened in Congo 20 years ago now, I remember moving missionaries out of Congo when it was really bad for 2 or 3 years. Companies will call for majeure. So you'll see that in the supply chain literature. If you look at the general supply chain literature, like how long, and depending on trade agreements, how long force majeure will be called for. But I think that's the bit that's missing between risk and resilience, is all of these different aspects of absorption, recovery, and longer term, immediate recovery and longer term recovery. I mean, it depends what level you're going to, but I think we're still at the early days of understanding risk in these supply chains. But I think as you start to get into the temporal and the spatial, then that'll have to come in.
Just going to comment on that. One of the things that Benjamin's been playing with is what does stockpiling of individual firms along the supply chain look like? And so if every firm in the supply chain has a month of material that they can use, you can eliminate a lot of your short-term disruptions to your supply chain. Say like maybe a machinery breaks in the mine, they can't mine for a few days, that doesn't affect you. But you get these nice cost curves of the cost of stockpiling versus the cost of reducing the risk.
So there's lots of papers on that in the chemical industry with some key authors, and if there's interest, ones catch me later.
Just tag stockpiling, it's always a...
Because there's downsides too.
Yeah.
Yeah, I wanted to add a quick point to this discussion, which is that a few times today there's been a kind of pivot of like looking at this from the perspective of sort of developed countries and global supply chains, and then switching around and thinking about the perspective of the resource holding developing countries. And I think this question of criticality and the definition of that is really important to do that, right? So sort of richer countries who are thinking about global supply chains and risks to, you know, manufacturing companies based in the developed world versus, I mean, I know a lot of stakeholders in Africa, I understand, are asking the question, critical for who, and not calling these minerals critical. You know, for us, these are not critical minerals, they're strategic minerals. They're strategic because they hopefully may be able to help us support our economic, inclusive economic development goals. So yeah, just I think the point, so it's like you've got risk, resilience, criticality, right? So I think the points you made, Jane, about the distinction between risk and resilience are really, really good and important ones. But coming to criticality, I think it's important to just take it from those two different perspectives as well. Think about the difference there. Thanks.
So what the company want to do risk will do opportunity as well. And that's the framing that you can use when you want to use for a developed country. And you do the two together, and see if you've missed something. Because the two should sort of add up.
It's an interesting one for me because, you know, even the UK's strategic critical mineral assessment is done from what we need to get for companies here. And I guess from a trade angle, maybe there needs to be a different set of critical minerals from a kind of an FCDO point of view, which includes this kind of the countries that we're working with and the risks in those countries as well. So it's an interesting thought. Good. I think we should probably stop there unless there's a burning question there. No, thank you for this, guys. I'm going to do a quick thank you and wrap up. Yeah, that one. So firstly, just thanks. Obviously, these days need lots of coordination, and so thank you for everyone for coming. Thank you for all the speakers, which have been great, especially those ones who have travelled. Thank you specifically to Luke and Laura, who kind of pulled quite heavily on the admin side of things and pulling it all together. That's great. Second thing is I just wanted to say, I'm going to jump this, but we are in the process of bringing together in the next couple of months kind of a new lab called the Cambridge Critical Materials Lab at Cambridge, which will really be where we centre this work. We've been working on this for about a year and a half now, and so Andrea and I are leading that, but also looking to reach out, particularly across Cambridge and other places, to make sure people are putting together. It's such a new space that everyone seems to be competing and not sharing, and so we're really keen for that kind of more sharing going on. So we've been doing, I can show you some branding stuff and some website design things coming your way. Also, as part of that, we've been pulling together, we've done some reports, so we'll be reframing our reports that we've written so far and kind of branding them a little bit to get them out into the market. So that's just a little advert of what's coming.